Okay, so we are continuing this conversation about introductory terms for thermodynamics. So I sent you off to the freezer to pull out an ice cube and hold it in your hand and write down your observations. So hopefully you've done that. So let's move on. So what I want you to do is now interpret those observations. So I got several questions for you. So question number 1, what represented the system in that ice cube sitting in your hand? Take a minute, figure out what you want to answer. The system was actually the ice cube. That's the chemical that we're interested in. Okay, so the system represents the ice cube. What represented the surrounding? Your hand, probably most likely, is what you would say. The air around the ice cube is also going to be impacted by the energy change. So anything that's not the ice cube that's in close proximity is going to be the surroundings. Okay, so remember that we have to use the surroundings to infer what happens to the system. So let's focus on the surroundings first. So the surroundings was your hand. Was energy leaving or entering the surroundings? Hopefully you said energy was leaving the surroundings. And how do you know that? Because your hand got cold. So your hand got cold, it was losing energy. Where did that energy go? The energy went into the system. So since the energy was leaving the surroundings and going into the system, that must mean that the reaction was endothermic. Okay, so the ice cube underwent an endothermic process, and it makes sense, right? The ice cube started to melt. So melting requires energy. To take that solid, what did we do? We broke some IMFAs in order to make that solid a liquid. So it took some energy to break those bonds. All right, the last thing we want to do is take a look at something called a thermal equation. So thermal equations are really just chemical equations that show where the enthalpy change is. So the delta H becomes part of the equation. So I'm going to use the two reactions that we watched the videos on. So the endothermic reaction, the energy is being absorbed by the reaction. So the enthalpy is going to be written on the reactant side, on the left side, just like it were a reactant. So here is that barium hydroxide plus ammonium chloride reaction. So it absorbed energy from the surroundings, which is why the ice droplet froze and allowed the beaker to stick to that wooden block. So it absorbed the energy, and what happened? It was able to convert the reactants into barium chloride, water, because you saw it get wet. And if you could have smelled it, you would have smelled a very strong ammonia smell, like smelling salts. So that's an endothermic reaction. You see the energy on the reactant side. If you were to write the enthalpy by itself, separate from the equation, you're going to write the delta H as a positive value. Okay, positive meaning we're adding that to the system. So endothermic reactions, you can probably guess, are going to be or exothermic reactions are going to be the opposite of endothermic reactions. So in this case, in an exothermic process, you're going to write the energy on the product side because its energy is being produced. Not only are the products being made, but energy is being made as the reaction progresses. So you're going to write it as the energy on the product side. Okay, notice it's plus the energy. It's not minus the energy, because what do we make? We make this and this and this as a result of performing the reaction. So 2 aluminums and the iron oxide are going to create 2 irons, aluminum oxide, and 851 kilojoules of energy, which is a whole lot of energy, which is why the iron melted. Okay, if we're going to write the enthalpy separate, we're going to give it a negative sign. Okay, now it's really important for you to understand it's not negative energy. It's energy that's being given off. It's energy that's being lost, subtracted from the reaction, taken away from the reaction. There is no such thing as negative energy in thermodynamics. Okay, it's just a matter of how the energy is moving. Is energy being gained as in an endothermic process, or is energy being lost as in an exothermic process. All right, so there's your introduction to a whole bunch of different terms. Hopefully the videos and the little activity helped drive those ideas home for you.